Hi, it's Terry Dennery of the MathWorks. So I was just kind of starting where we finished off from the last video. We did this comparison between code produced by MotionGenesis and embedded into a MATLAB function, right, that essentially calculates the dynamics of this, well, the dynamics of the mechanics of the robot itself. And then we did a direct comparison, and yeah, think we saw we did pretty well for the first 2 seconds, and ultimately the two solutions separate, right? And so, really, this is kind of an accuracy versus stability issue. And certainly if something goes unstable, of course, things become inaccurate, but the two terms are kind of treated differently. And so what I wanted to really get into on this one is, okay, let's not worry. In a way, here's what stability is about. Okay, it's not about formulating the problem accurately. It's more about solving the problem in the best way. All right. And so, of course, there are good numerical things you can do, and certainly unstable systems do exist, and you use controls to kind of make sure that they end up doing what you need them to do. So, anyways, but let's kind of get into that idea of accuracy of the formulation. And ultimately, what this block and what really Simscape Multibody is doing for you is really formulating the relationship between the forces and torques that are applying on a system and the motion that you get. And so in this first kind of validation, we just kind of showed that, well, for the forces that we're giving, which were mostly gravity, that at least for the first 2 seconds, we got a pretty accurate simulation, right? So anyways, um, kind of I think, important reasons for doing this too is how we're going to take what we're doing in this and do it in the controller too. So anyways, here's what I want to do. I want to delete that file because we're about to recreate it. And we recreate it with this other file that was created for us on the export from SimWise into MATLAB and Simulink. Right. Right? And this one's going to look quite a bit like the file we used in MotionGenesis before. It's going to be the same rigid bodies, same masses, inertias, same coordinate systems, but we're going to set up the joints a little bit differently, the motors, let me be more specific. And that we'll see it kind of here, that we're going to kind of set up these variables. It's a little bit different. It probably could have been maybe a little closer to what we did, but the way we're going to solve it's going to be different. And so we're going to solve those same Keynes equations, but this time, we're going to solve for the torques in terms of the motion, as opposed to the motion in terms. Actually, what we did before wasn't solving for the motion, is solving for the second order derivative on each of those motor angles, right? So this time we're going to solve for the torques. So let's just go Control A, Control C. Let's go to MotionGenesis. Let's paste that in, and let's watch it crunch. Again, I think we're going to see a little bit of, let's call it user error, or let's call Terry needs to be trained a little bit more, on MotionGenesis. But again, I got good access to kind of people can help me out with this, and certainly we'll kind of see this as we go through this. So again, all those equations are getting crunched. It's essentially saying I do not have initial conditions for all these motors, so let's not quit. Just keep on allowing the default assignment of 0, which really is the assignment for the angles as defined for a vertically positioned robot. Right. So we'll just go in here and enter these. All right. And with that, we'll see that that file that I deleted has been replaced, and it's back in there again. All right. And so MG robot video specified. Okay. And so again, I can do a little bit of this stuff that takes a few minutes to do. And so I think I'll go quiet, probably edit this too, but essentially set up the, my order actually will be DDT. Here's the way I'm going to do it. Okay, Control C. It will be turntable first. And I'll just go comma space, comma space. And so we're going to send it each motor command in terms of position, velocity, and acceleration. And so you'll see these variables that were created for us by MotionGenesis, DDT, being the second order derivative, dt, and then we'll leave the ddt there. All right, so anyways, I'll go quiet. I'll do all this stuff and I'll probably edit it out. So I'll be back in a sec. Okay, so I got that function statement in. Oops, I copied all this up here just so I could get those names in. So let's remove that. And it's a big deal on MATLAB that you like your variables are sent into and out of a function not to be highlighted in yellow. We've talked a little bit about the rest of the variables do not care about the position of the turntable. And this is simply telling me that that variable is nowhere in here, where all the other ones, absolutely, you'll kind of see them appearing. So let's just go ahead and delete that. Okay, and when we, oops, oh, we didn't put this in the MATLAB function yet. Oops, that's not what I wanted to do. Anyways, let's go Control A, Control C. Here's that function we just had. Let's go MATLAB function. There it is. Let's make it kind of big. It's going to have a lot of inputs and outputs. And we will paste that in like that. And now when we come back out here, we should see all the function statement kind of choices we made kind of show up, setting up the input and output. Okay, so this time we're going to compare torque. And so here's our Simscape Multibody file. And no longer are we doing motion. And so we're going to just reconfigure our bus selector to be torque. And we'll trash can motion. All right, so that one's good. So let's just delete these. Okay, and so then we're going to replace this MotionGenesis code, put it in that MATLAB function with this, and we're going to need to set this one up a little bit too. So let's zoom in like here, all right? And then we're going to mux block. Actually, I want to get, is it mux or demux? I want to get demux. Come in as one signal and distribute 3. Oops, let's put that third port in there. And see if I can get this size reasonably quickly. Yeah, pretty good. All right, and recall that we're only sending in velocity and acceleration. So we, for the turntable, so we'll terminate the position. Right. And we'll have an input here. And we will call that TT, and then I like this little designation PVA. Right, and so we'll kind of redo this a few times. And then this one will be the bicep PVA. And this one will be the forearm FA PVA. Wrist, so WPVA. And then this will be the hand. Okay, and so now I'll pop this into a subsystem. Get rid of all that stuff. And now match the size of this one. And we will delete that and put this in. All right. And now I think I kind of got what I want. Now this one won't move, and we will not really have anything to measure or compare. It's a good idea to hit run still, see if I made any mistakes. This is our first time running of the code. And it should be 0 is equal to 0, basically. Okay, I'm good so far. All right, so let's go to my Simulink browser, and I'll get some motion profile. So smooth step position. All right, and I think I'll start on the forearm. And let's go, starting at 1 second, let's have a 1/2 second transition where that motor will undergo a transition from 0 degrees to 90 degrees, which within this field, I will convert to radians by multiplying by pi over 180. Okay, and so for both models, that will set the forearm position. So let's see how we do. Ah, okay. Rookie mistake. I didn't reconfigure my Simscape Multibody model to be a receiver of motion. Okay, notice it's now receiving PVA. Let's run it again. Looks pretty good. Could give myself a more refined time step. So make the maximum time step 0.01, and we'll get smoother curves that way. And when we just look at this one this time, you can see they all look pretty good. All right, and just make sure we weren't just lucky. Let's maybe put in a couple other actuations, and so we will, at 2 seconds, bring the wrist down, that same amount, and then at 3 seconds, let's rotate the wrist, or rotate the hand actually. All right, and all these got to be brought down too. So wrist, hand, okay, and well, let's recalculate. We should see more going on this time. And we do, and we see really, really good correlation. So at this point, I think I'm pretty convinced that we got the model correct, that they are equivalent, what we're doing in multibody as well as MotionGenesis. And I'd say it's up to me now to make the case that having that in lines of code is really, really valuable. The fact that it's compact code that runs really fast, that sounds really good. I think I'll make that case pretty well too. All right. Anyways, thank you.